Okay, today is the last day of the longest month of the year. 331, March 31st, last day of March. We survived it. Yay! 2 more days and we're off to spring break. Fantastic. Okay, today we're going to talk about proportional and non proportional graphs. So, proportional and non proportional graphs. Okay, so I asked you this before, and I got one student who said yes, but then that's about it. So let me ask you again. Of all the graphs that we've done these last 2 weeks, since March 15th, so these last 15 days basically, what have you noticed about all the graphs that we've done and the classwork graphs? What can you tell me? What do you notice about all the graphs that we have done in this class for the last 2 weeks? There's two things that you should be noticing. Two things. There's always an equation. Okay, so there's three things you should be noticing. There's always an equation. Not what I was thinking, but you are right, Jaime. What else do you notice about all of these graphs? Every single one is proportional. Yes. So Saeed, what makes it proportional? They're all proportional. So what makes it proportional? What makes a graph proportional? So I'm trying to see if you guys can figure out without me directly teaching it or directly telling you, because I kind of already taught it, telling you what makes a graph proportional. What makes a graph proportional without me telling you it's proportional? What can you look at to make it proportional? Oh, let me see. They all have the same number that go into the number. Yeah, so the constant of proportionality. They all have a constant of proportionality. Okay. If I were to show these graphs, if I were to show these three graphs, none of the equations, right? Just a simple graphs. And I showed it to a fifth grader who doesn't really know much about proportional relationships. Just a fifth grader. So put yourself into fifth grade shoes. What do you think they would tell me? And I would say, don't look at the numbers, just look at the graphs. What can you tell from the graphs? Just in general, with the fifth grade mindset. What do you think of fifth grader? Oops. So this is a graph. There's no numbers. You should be able to determine if a graph is proportional without any numbers. That's how you should be able to tell if it's proportional. If it's graphed, they already graphed it for you. They're just asking you, does this show proportional relationship? They don't need numbers. You don't need numbers to prove it. That's how obvious it should be for you, but it's not based on the answers I'm getting. So here it is. In order for a graph to be proportional, it must satisfy two things. It must be true for two things. The first thing that it must be your graph line. My graph line is pink. My coordinate plane is green. So that's what is there on the worksheet. And then you come along and you draw the pink line. There's no numbers on here, right? So it's a general statement that for it to be proportional, for a graph to be proportional, it must be, number one, a straight line. Have you graphed a line in this class for the last 15 days that hasn't been straight? No, they've all been straight. Number two, the second thing that it must have, it must go through or start at the origin. Does anybody know what the origin, where the origin is? What the origin is?
Where x is 0 and y is 0?
Very good, Saeed. So the origin is at 0, 0. Now remember when I made a big deal when one of you didn't connect it to 0, 0, you would just connect it here and go up, but you would forget to do that one. I was like, so good. A lot of you do know what origin is. So in order for a graph to be proportional, so a proportional graph, proportional, it has to meet these two criteria. It has to be a straight line, and it has to go through or start at the origin. So this is the origin. So we started at the origin and it's a straight line. This makes it proportional. If you just look STRAIG, maybe you don't, sorry. This is my H. This is my I without a dot. Did I do it right now? Just my H looked like an N and my I didn't have a dot, which is why I have messy writing. Sorry. Okay. So proportional means it starts as, it's a straight line and it goes through the origin. So if you look at all the graphs that we've done in the last 15 days, all of them start at the origin and all of them are a straight line. So if I were to ask a fifth grader, hey, fifth grader, what do you notice from these three graphs? I'm pretty sure one of them would say, oh, they're all straight lines. Okay, cool. What else do you notice? Well, they all start like here at the corner. I'm like, you're brilliant. Let me skip you to 7th grade. And they'll be like, okay. Perfect. All right. So here's a non-proportional graph. So because it's proportional, you can write an equation for it, right? And you can figure out what number you're multiplying by, like what's the unit rate. So because it's proportional, you guys can find the equation, you guys can find the unit rate. Yay! When it's not proportional, let's go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Simple graph. Up by ones. Okay, so let me graph this one. So notice where I put my dots. 0, 2, 1, 3, 2, 4, 3, 5. So this graph is not proportional. Why not? It's a straight line. You're right. It is a straight line. It is very much a straight line. What does it not do? It does not start at the origin. Here is 0, 0. That right there is called the origin. Okay? 0, 0, right? It doesn't start at 0, 0. And that's not a good thing. Like if this was a table, and I actually draw my table this way, which is the same thing I did the other way. When it's x is 0, y is 2. And then x is 1, y is 3, 2 is 4, 3 is 5, right? And you're like, oh, look, Miss Amelie, we're going up. We're going up by ones. Look, everyone goes up by ones. Here we're going up 1, 2, 3. You know, yeah, it looks like it's in order. Look, Miss Amelie, we're going up by ones here. Here it's 1, 2, 3. It's super awesome. It looks really nice and neat. It does. But this right there messes everything up, right? At the beginning, we always, like stress like, well, how much does zero boxes of cereal cost? You would say 0. And it's like, yeah. And you probably didn't care about 0, 0, but I kind of did tell you, like, it's the second most important point, 0, 0, 0, 0. Because if it's not 0, 0, like as soon as you see that it's not 0, 0, either on the table or on the graph, you can go like non-proportional, I'm done, right? So as soon as you see it doesn't go through the origin or on the table, it's not 0, 0, it's called non-proportional, okay? In 8th grade, you'll be doing these problems, these equations, these graphs in 8th grade. In 7th grade, nah, we want it at 0, 0. All right, are we okay? So let's do another graph. Let's just do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Just simple graph. Just create those. Okay. So this one's going to start at 0, 0. 1, 1, 2, 3, 3, 2, 4, 5. What? So these are the points. 0, 0, 1, 1, 2, 3, 3, 2, 4, 5. So those are my points. And if I were to connect these, you can see right away that it's not a straight line, right? It's not a straight line. It's even not a straight line just right there. Like if you just look at it, looks like a straight line, but this doesn't go up by 1. It skips over to like 2 should have been 2, but 2 is 3. So the angle of the line is more steep. So obviously I made it this way so you can clearly see that it's not a straight line. But technically, even right there, it's not even a straight line there. But it's just harder for kids to see it. But here it is. On the table, it wouldn't, you wouldn't go up by the unit rate. The unit rate would keep changing. Okay, so these are just 2 examples of non-proportional graphs. So non-proportional means it's either not a straight line or it doesn't start at the origin or both. So it could be like it's crazy, it doesn't even start at the origin and it's not a straight line, or one or the other. It doesn't have to be together. As soon as one of these is not true, it's over. Game over. These 2 must be true. It has to be a straight line and it has to start at the origin in order for it to be proportional. Anything else is called non-proportional. Okay? So let me show you some examples.